This is a video lesson for Unit 4, Lesson 4, and it's on point-slope form, which is a special form of a line. Slope-intercept form is the form we were just dealing with, and it gave you the slope and the intercept. This lesson will give you the point and the slope of a line. This lesson's about graphing and writing, but writing is what we're going to focus on the most. So if you notice, I highlighted already point-slope form to give you an idea of what you're seeing in this form. So it's y minus y1 equals mx minus x1. The components of this formula start off with y and x, which are just the two variables that we're actually interested in. So you never actually plug in for those, they're just there. Now, the second part, you'll notice, is the slope, which is nothing new to us. We had that in y equals mx plus b, so m is still slope. But now you have this interesting idea that you have an x1, y1 within the formula, and that is an ordered pair for a known point on the line. X and y are not known, so they just stay x and y. But x1, y1 will be a known point on the graph, so we'll be able to plug in for those. So the first thing we want to do to get used to this formula is take a look at a couple of equations already written in this form, and we're going to pick out the key ideas about it. So if you look at this and you put y minus y1 equals mx minus x1 on top of it, you can kind of see what lines up. 7 lines up with x1, so this point is really x1, y1. So 7 is going to be our x1. The y1 lines up with 3, so we're going to put a 3 there. You might be thinking, well, it's a negative 3. But no, the formula is supposed to be subtraction, so it's 3. Now the slope right here is just negative 1/3. So you can use the equation that you see just to quickly fill in the information you need. Now, it's a little bit different in this second one, and people will get confused by this. The slope's not hard, that's 5. But where people will get confused is that it's supposed to be, and let me just write this on top, it's supposed to be minus x1. So we're supposed to see a subtraction, but I see addition. I see plus 2, okay? What that really means is that we were subtracting a negative 2. So the x value there is actually a negative 2. Same thing over here. We're supposed to see y minus 1, but we're actually seeing plus 3. So to be plus, you must be subtracting a negative. So it's really minus negative 3. So negative 3 is the y value. That'll get people confused, so really take your time looking at that. Now, I had a little typo on here, but I fixed it. It should be fixed on yours. How do you write an equation using point-slope? It's really simple. Find m, find a point, plug them in, simplify. That's all we got to do. The first couple problems we're going to see, I'm going to be nice with it, and we're just going to ask you to write it in point-slope, so you can just plug in and be done. The next problems we see after that, we'll actually have to do some simplifying. Okay, so the first thing that I want to do is, again, write my formula. Y minus y1 equals mx minus x1. It's point-slope form. It's very important. This is our x1, y1. It's an ordered pair that we know. That's what we were looking for. And this is obviously our slope, m. So step 1, find the slope. I found it. It's 2. So I can plug that in directly above. My slope is 2. Okay, my points, plug them in here. Well, no matter what, we're going to write y. Y and x are always going to be there. So I've got that y minus something. Okay, it's minus, in this case, 7, because y1 is 7. So y minus 7 equals, so that 7 goes right here. And then it's x is still going to be there, minus, well, it's minus a negative 3. Subtracting a negative 3 turns it into addition, so it's plus 3. When you subtract a negative, it becomes addition. So x minus negative 3 becomes x plus 3. And this is our answer in point-slope form. So we're just going to be done. We're just going to stop since it's in point-slope form. The next problem, number 4, you might think, well, I've already done this kind of problem. We found the y-intercept first. But if you look here, this y-intercept is not in a very nice place. So we're actually going to have to use the points on the graph to find the slope and to pick a point to create this point-slope problem. Okay, so again, I'm going to be using y minus y1 equals mx minus x1. I'm going to draw a little squiggly to show this is a new problem and just rewrite the formula right here. Okay, now, as we look, the slope, I'm going to find grid points. So here's a grid point and here's a grid point. I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So 4/5 is my slope. We needed that. Remember, step 1, find the slope. Right here, step 1, determine the slope. So my m equals 4/5. A point, I just need any point on this line. I'll just use this one right here. This was at 2, 1. I know I've kind of drawn on it, so it might be hard to see, but it's 2, 1, which is my x1, y1. Now, some of you might be thinking, why don't I use this point? And you can. It would work. Okay, I'm just going to use that 2, 1. And you might think, how are they both going to work? But when you simplify it, it's going to work no matter what, as long as you're doing it right. So I'm going to take that information and plug it in. Y minus, and that's going to be 1, equals m, which is 4/5, x minus 2, which was x1. And that's our answer. Now, some of you might have an answer of y minus or y plus 3 equals 4/5 x plus 4. And that would just be because you used another point. And what we're going to see in the next couple problems is even if you use another point, when you simplify, you'll still get the same equation. So there might be multiple right answers when you're in point-slope form, but they'll all turn into the same slope-intercept form. So now we move on to number 5. And this is where we are asked to actually go all the way. And this is the most common type of problem and what you're going to see on the test. We're going to be asked to go all the way into slope-intercept form. So we're going to start off. We've got our point. We've got our slope. So step 1 and 2 are done. Here's step 1. We have a slope. Here's step 2. We have a point. x1, y1. I like to label it. Okay. We're going to plug it into point slope. Y minus y1 equals mx minus x1. That's going to be y minus negative 4, which is y plus 4, equals m, which is negative 1. We're just plugging this in over here. Okay, x minus 5. So y plus 4. Now we're actually going to simplify. We're going to clean this up. Well, equals, well, we don't need that negative 1, but what we could do is we could distribute with it negative 1x, or just negative x. Negative 1 to negative 5 makes a positive 5. What we're doing is we're working our way towards slope-intercept form. Y equals mx plus b. So we plugged into point-slope form, but now we're finishing into slope-intercept form. So we're going to keep going. We're going to subtract this 4 and get y equals negative x plus 1, which is in slope-intercept form. So really, this step over here, when we plugged into point slope, that step was really just a work step. It's not a final answer. Point slope is a way to get to slope-intercept form. So let's do one more problem here, number 6. So for number 6, we have 2 points. So finding that slope, step 1, finding the slope, a little bit harder. We're going to have to use slope formula. We're going to get m equals y2 minus y1 over x2 minus x1, which is going to be negative 2 minus 8 over 3 minus 5, which would be negative 10 over negative 2, which equals positive 5. So that's our slope. Slope is 5. So y minus y1 equals m x minus x1. Now, as far as the point is concerned, because step 2 is to find a point, didn't I already call a point x1, y1? Let's just call that one our point. You could use point 2, 3, negative 2, but I'm just going to use the first one since it's already labeled. It's already labeled x1, y1. So we're going to plug that in. Y minus the y1 is 8 equals m, which is 5, x minus x1, which is 5. And now we're going to simplify it one more time to get it into slope-intercept form. So we're going to distribute on the right, and then we're just going to add over whatever that y was. So y minus 8 equals 5x minus 25. And then we're going to add 8 to both sides. Y equals 5x minus 17. And that's in slope-intercept form. Y equals mx plus b. And that's done. Now the last problem that we're going to do is really a problem that you already kind of know how to do. There's just one step we're going to do. The first thing in this problem is we're going to get this into, because it's graphing and we know how to graph from mx plus b. So we're going to modify this guy to be y equals mx plus b. And we're going to do it in the exact same way we just did this stuff over here up top. We're just going to distribute and move over that y value. So we're going to distribute the 3/2 x, which if you want, you could look at it as a decimal for right now. I'm going to leave it as a fraction. But we're going to have y plus 2 equals 3/2 x plus 3/2 times 4, which if you need to do it off to the side, 3/2 times 4 over 1 equals 12 over 2, which equals 6. You could also use a calculator for that. But when you take 3/2 times 4, you get 6. And now I'm just going to subtract 2 from both sides. And we're going to get y equals 3/2 x plus 4. And from the previous lesson, we know how to graph this. We know that 3 means go up 3, 2 means go right 2, and 4 is our b, which is where we start. So we're going to start at 0, 4, and we're going to go up 3, 1, 2, 3, and over 1, 2. And there's our next point. And then we can go backwards by going down 3 and left 2, down 3 and left 2, down 3 and left 2, till I run out of room. And we've got all the points we need to graph the line. So the summary on how you graph using point slope is pretty simple. Don't. Just get it into slope-intercept form and then graph it that way, because that's the easier way.